This is BeerSmith episode number 118, and it's early January 2016. This week, Krzykwa from Industrial Test Systems joins me to discuss measuring your water and mash pH. Thank you to this week's sponsor, Craft Beer and Brewing Magazine. You get 6 amazing issues each year, packed with information for brewers and beer fans. They're offering a new discount code now, which gives you 15% off everything they sell. The new code is BeerSmith 2016. I encourage you to check out this great magazine for homebrewers at beerandbrewing.com and use the offer code BeerSmith 2016 to get your 15% discount today. And also Anvil, new kettles, burners, and accessories to help you forge the perfect beer. Anvil's a new line of brewing equipment from Blickman Engineering, endorsed by brewing author John Palmer. Anvil is durable, reliable, quality line of brewing equipment built to last. Find out more about Anvil at anvilbrewing.com. Again, that's anvilbrewing.com. And also BeerSmith, design great beer, brew with confidence, and brew your best beer every time using BeerSmith software. BeerSmith lets you create your own recipes from scratch and access thousands of recipes found on the BeerSmith cloud. Also, our desktop and mobile versions work together seamlessly to make your brewing easier. Give BeerSmith a try today by downloading the free 21-day trial from BeerSmith.com. Get your free trial today at BeerSmith.com. And now let's jump into this week's episode. Today on the show, I welcome Krzykwa, who is Technical Product Manager for Industrial Test Systems. They make water quality test kits, including the Smart Brew test kit. Christian, it's great to have you on the show.
Great to be here.
So how are you doing today? You enjoying your new year?
Yes, sir. Yeah, I'm enjoying 2016 so far.
It's been a pretty good year, the first couple days anyways.
Mm-hmm.
So you've been working in industrial test systems for a while, and you guys are into water quality testing, right?
Yep. I'm a recent college grad. I've been here about a year, and Industrial Test Systems has been testing water quality for about 25 years.
Fantastic. And I guess the big innovation is you guys have recently moved into home brewing, right?
Absolutely, yeah. In the last year or so, we've moved into home brewing. We went to a homebrew conference on the West Coast this year, and since then we've really tried to adapt our testing to fit the needs of homebrewers. Yeah,
that's actually where I met. I think it was George Bailey was his name, right? George.
Yep. He's our VP of Marketing and Sales. He was out at the conference, and we learned a ton about home brewing and how our water testing can really fit the homebrew end user.
Very cool. Well, let's talk a little bit about water quality testing. Why is it very important for people to understand what their water quality is and what their water is actually made up of?
Well, there's numerous different parameters that people tend to check and measure when you're getting into water quality testing. You might get a water report from your water municipality that says that you've got certain alkalinity ranges, certain calcium, certain magnesium ranges. And for someone without a chemistry background, that could be difficult to interpret. So a little bit of background information, a little bit of research and reading is necessary to understand how that's going to affect your brew, because each parameter is going to have a different sort of consequence when you throw it off or adjust it.
Now, a lot of people rely on the water reports they get from their local water source, and you guys have actually moved into allowing people to test their own water, right?
Yeah, and the main reason that that's really important is when you're getting a water report from a municipality or your local government, I guess that's more or less an average, an estimate of what could be coming out of your tap, but these trace elements that are in your water, they can vary so much from one day to the next, from 1 week to the next. So you really don't know what's coming out of your tap. That's not necessarily in a bad way, but when you're trying to have very precise ranges you're looking for, it's a lot better to do the testing on site or a sample specific type of test. So I know some brewers have gone into getting their water tested at a third-party laboratory, which can be cost prohibitive if you're doing it every time, sometimes multiple times. A lot better to be able to test at home.
Very cool. And that's what your kits allow, right? You can test at home.
Absolutely. It uses some of the same methodologies that you would see in a laboratory, but we've geared the method to the end user, making it really so simple that anyone can do it, but you're still getting that high quality chemistry that you might be looking for out of a laboratory.
Okay, well, let's step back for a minute and just talk about what are some of the things people would look for on a water report. Let's say you get your municipal water report in, and what are the things that are important for a brewer to look at?
Well, the things you might see are your primary water standards, alkalinity, pH, hardness. These are things that you'll notice right off the bat. They'll include, pH. Let's start with pH. It's one of the most important parameters, especially in the brewing process. So a starting pH isn't going to be affected that much until you start to heat that water and combine the ingredients. But what will have a big effect on that is the alkalinity. Alkalinity is essentially the measure of that pH to resist change. So let's say your pH starts at just under 7, 7 being a neutral pH. Let's say tap water can be anywhere from 6.5 to 7.5. It's usually right around 7. But if you've got a high alkalinity, it's going to stay right around there. Alkalinity is a combination of carbonate and bicarbonate ions that help those hydrogen and hydroxide ions stay where they need to be.
And most water we get tends to be slightly alkaline, right?
Yeah, alkaline meaning above 7. It's also known as basic. Most water that you'll receive because of what's added to it in the water treatment process is slightly alkaline. If you've got filtered water, though, if you're using a carbon filter or an RO filter, that will tend to be slightly acidic.
Mm-hmm. And you talked about the alkalinity of the actual water itself being its resistance to pH change, right?
Absolutely. So the higher you have for that alkalinity reading, it's usually read in units of calcium carbonate. That doesn't mean it's actually representative of calcium or carbonate. It's just a unit. For example, if I have like a piece of wood that is so many inches, it's not made out of inches. I'm just reading it in inches.
Right. So you typically see a number alkalinity as parts per million of calcium carbonate, right?
Right, exactly. So, and you'll see the same units on other measurements, like magnesium readings as calcium carbonate or calcium readings as calcium carbonate. They're all the same units, but can give you different indications of what's going on in your water. So back to the alkalinity, the higher that number is, the more resistant to change that pH is.
And that becomes very important when we get to the mash, which we'll talk about in just a minute. Mm-hmm. I wanted to also focus on the big 6 water ions that most brewers are concerned about. What are the big 6 water ions?
That would be carbonate, sulfate, chloride. Let's see, I've got it here. Let's see. We have carbonate, bicarbonate, sodium, chloride, sulfate, calcium, and magnesium. So where each of those kind of fall into place, the carbonate and bicarbonate are representative of your alkalinity. The sodium and the chloride, that's a measure of salt, so that's going to affect the flavor quite a bit. The calcium and magnesium, that's your hardness. That's going to affect some of the yeast and the health of the biological components of the brew. And the sulfate will also have a big effect on the flavor of the beer. Awesome.
Well, let's look at the first 2, calcium and magnesium. They both come into play when determining the hardness of the water. What role does hardness play when you're brewing beer?
So hardness, in just a general water aspect, it tells you how much the water is going to calcify, meaning how hard the water is how much the water has a tendency to scale. Calcium and magnesium both have a tendency to deposit when it's heated up. So that calcium and magnesium will actually tend to fall out of solution as you heat that brew.
So some of us get like a hard deposit sometimes at the bottom of the brewing pot. That's probably what that is, right?
Yeah, that's due to excessively high levels of calcium and magnesium. So your tendency might be to bring those values way low, but that might also be detrimental. You need a certain level between 10 and 50 ppm of that hardness to be able to maintain the health of the yeast. The ions in the water are able to help that fermentation process along a little bit.
Cool. And you mentioned small amounts of magnesium are important for yeast health, right?
Right, absolutely.
Well, sulfate and chloride come into play, particularly when we're looking at the hop balance of the beer. What is the sulfate to chloride ratio, and how does it affect the bitterness?
So the sulfite chloride, let's see. What I have here is that sulfate levels are typically 10 to 50 for pilsners and 30 to 70 for most ales. And you're going to want chloride levels that are a bit higher. So you're going to want normal brewing at 150 milligrams per liter and 200 milligrams per liter would be the upper limit of that. I, myself, not being a brewer, I don't know exactly how that can affect your taste, but I do know that's an important thing, an important parameter to be able to test.
Mm-hmm. Yeah, as a ratio gets higher, it generally supports, I think, more bitter beers is what I recall off the top of my head. So finally, you have bicarbonate along with calcium and magnesium, and that drives the residual alkalinity for the water. What is residual alkalinity, and what does that really represent?
All right, residual alkalinity is it's a brew-specific parameter. It's not something we see in any other industry. It's the ability of that alkalinity to affect the pH in the mash. So what happens is when you add your hops and your other components to the brew water to get those levels just where you want them to be, then you're going to heat that solution. And calcium has the special property that with heat, it tends to deposit more. Whereas if you think of something like sucrose or salt or sugar, those will actually dissolve more with heat. So whenever you heat that solution, the calcium ions tend to attach to the carbonate and bicarbonate ions and fall out of solution and create that deposit that we talked about earlier. What you have left is what we call residual alkalinity. That's the amount of carbonate and bicarbonate ions that are left after that heating process. You want that alkalinity to be high enough so that after you heat it and the calcium has fallen out of solution, you still have enough alkalinity left in solution to keep your pH from dropping way down.
Right, and all this rolls into controlling your mash pH, which is perhaps the most important thing when you're brewing all grain. What's the target level for the mash pH that we're shooting for, really?
I believe you want a mash pH that's around 5.4 to 5.8.
It's roughly 5.2 to 5.4 is what I recall.
Oh, okay.
Yeah.
All right.
And that's really critical for the flavor stability of the beer. And as you mentioned, the water tends to be slightly alkaline, right? And has some alkalinity to it, some residual alkalinity to it. And then we mix in these grains, which tend to be slightly acidic. And so the net is you get a pH overall that everything nets out here, right? Right.
Absolutely.
And so depending on what your residual alkalinity is, that tends to drive how dark a beer you can brew, because darker grains tend to be more acidic, right?
Right. So that would mean that you have to adjust that alkalinity proportionately to create a residual alkalinity that's going to be able to stabilize your mash pH.
Yep. And so our goal is to understand the water profile, right? Which will help us balance the mash pH out in the mash.
And after you're able to understand the water profile, and say we're just looking at a water report you might have gotten from a municipality or a third party, then you want to be able to make those minute adjustments from brew to brew and be able to test your own water so that you can create more specific water profiles. And that's what the Smart Brew Kit kind of allows you to do, is to make minute adjustments.
Very cool. And even if you know the residual alkalinity, even if you know the water and the grain bill, it becomes very difficult to predict the mash pH, right?
Yeah, there's really no substitute for testing the mash directly, because with all of the math that you can do, there's just no way to account for every possible scenario. The temperature, the concentration of each of these 6 ions, the concentration of your hops and your grains and everything else can all play a different role. And it's really difficult to account for every different scenario.
Yeah, I've talked to commercial brewers, and they say that the grains vary tremendously from batch to batch, and sometimes even from season to season. For the same grain, same malt bill from the same manufacturer, they can actually see wide variances. So it really becomes important to measure your mash pH, and how do you go about doing that?
So the way we suggest that you measure a startup water pH is a photometric method. So you take a sample of water and you add an indicator, turns a certain color, and then you know what your pH will be. Well, the mash being a colored product already, it's almost, here's a picture of our photometer. That's how you would test the startup water. Within the Smart Brew Advanced Kit, what we include is actually a pH probe that uses electrochemistry, meaning that it has a glass not a photo tube, but a glass basically tube that allows certain ions to penetrate it, and it can give you an indication of how that pH has changed. So if you go back to that screen for me,
sure,
you'll see the Smart Brew Advanced Kit right there has the pH probe. That will give you a digital readout simply by dipping into.
I've actually got one here. Here's one here. This is it.
Oh, excellent. Yep. So inside that cap is two probes, and the probes measure basically how much electrical current it takes to transfer from one to the other.
Right. I think.
Yep. Exactly.
And I mean, what are the advantages of using something like this over simple test strips?
That's much more accurate, much more reliable. It's a test strip is going to give you a best guess, so to speak. I know that test strips from Industrial Test Systems, we guarantee that it's within one color block reading. So I don't have a color chart in front of me, but a color block would, let's say, be from 5.2.
Yeah,
to
maybe talk about how you use a test strip real quick. Maybe a lot of folks haven't used them. I hope most people probably did it in basic chemistry, I guess, in high school or something. But
right.
But I mean, a test strip's just a little piece of paper, right?
Mm-hmm. So one thing that you might have seen in basic chemistry is litmus paper. That's actually, it's like a giant test strip. It's a piece of paper that has been embedded with a chemical. You drop some water on it and it will turn a color. A test strip uses similar technology, but you dip the strip into the solution, you'll move it back and forth for a few seconds, pull it out, give it a quick shake, and compare it to a color chart. Let's see. I don't have one in front of me, but right. The color chart will represent the colors, the different color changes you might see on the pad. So one color block might have a reading of 5.3, one might have a 5.4 and a 5.2. You have to make your best color match to that test strip and that pad, and then you can still only guarantee that it's within one color block. So you have a lot of variability in that test strip, whereas if you get a digital readout from the probe, you're getting a much more reliable readout.
Right. And one of the things you definitely don't want to do is go out and buy like a pool test strip. I mean, you actually need a test strip that's designed around beer brewing, right?
Yes, you need a test strip that's specifically designed to test in warm water solutions because, like I was talking about, how the heat affects all of the calcium and alkalinity, those ions, it can affect the chemistry within that test strip just the same. And if it's not been calibrated for warm water, then you aren't getting reliable results.
Well, and the other problem is you want something that works in a fairly narrow range around the 5.2 range because a lot of them are designed to operate at 7 or 8 or 6, and so you're going to get not a very accurate reading, right?
Right. A pool test strip is designed to read it. The ideal level for a pool is 7.4. So it's really not calibrated in the range that you're looking for.
And of course, the advantage of using something like this is you literally just dip it in and you get a very accurate reading, right?
Yep, absolutely. You do have to calibrate from time to time with some deionized water or calibration solution with that instrument. With the photometric method, the method that you might be using for your startup water, that never needs to be calibrated. And it's very simple, same as using a test strip, but it uses a light source so that it can be more accurate as well.
So after we've measured our mash pH, usually we have to bring it down. In most cases, I mean, there are some rare instances where you want to drive the mash pH up, but because of the alkalinity, the acidity of the mash, particularly when you're brewing a light beer, you often want to drive it down. What are some of the additives you can use to help drive your mash pH down?
Let's see. You can use things like sodium chloride, gypsum, calcium chloride, Epsom salt. Those are all going to help to balance those sodium, calcium, chloride, and sulfate ions. You can use baking soda, which is sodium bicarbonate, to adjust your alkalinity, and you can use.
And those are good. Those are typically going to drive the pH up, though, correct?
Right. So you can use acids, citric acid, or some other special product designed. I'm aware of products on the market that are specifically designed to drop the pH.
Right. So typically when you add some of the other things you mentioned, some of the water additives, that will drive the pH up a little bit, particularly things like bicarbonate and stuff like that. And then if you add acid, it will drive the pH down, right?
Right.
And most homebrewers have access to lactic acid is sold in a lot of homebrew kits. That's one that a lot of us use. And probably the other one that's very common is acid malt, which you can buy, which has a little bit of lactic acid in it. It's actually produced using a souring method. Those are the two that most people use. Your company, we've been talking about it for a while now, the kit, which is called the Smart Brew Kit, which includes a water test. We already talked a little bit about the pH meter, but it also includes this thing called an iDip.
Yep.
Right? Can you talk about that for a minute and what that actually does?
Absolutely. So I went over a little bit of the technology in a test strip. It uses a reagent that's kind of bound onto a pad, and you have to compare the colors to one another. This does the same general concept, but what it does in place of you having to visually interpret the color change, it uses that blue device, that iDip, it takes a LED, much like what you might see on a remote control that lights up, just a single wavelength LED, to shoot a beam of light from one end to the other through the sample. That takes a 0 reading before you add a test strip. And then after you put the strip, it's called a reagent strip in this case, because you aren't going to read it. You're just going to dip it in the solution for 20 seconds, throw it away. And then the photodiode will be able to read the difference in light. It's essentially doing that color analysis for you right in the photometer. It then sends that information to your iPhone for a calculation, iPhone or Android device, for a calculation. Once that calculation is done, it will represent it as a value that you can use in parts per million, milligrams per liter, whatever you may use in your water report.
So it comes with, you got these little bottles here, I guess, right?
Yep. Absolutely.
And this one's marked alkalinity, so I assume I can measure my total alkalinity with it, right?
Right. So the way that works is it works in conjunction with a smart device, either Apple or Android. So you would start up your, let's say, iPhone in this case. You download the free app from the App Store. Then you would take your photometer. It will sync automatically via Bluetooth, so it's completely wireless. You collect a water sample. It's completely waterproof, so if you were inclined, you could dip it right into the sample That's more useful in situations where you've got where you like pool. The pool market uses that a lot. They will dip the sample directly in the pool. For the brewers, you might be more inclined to take a sample of water and test it off to the side. But anyway, it's completely waterproof. So you fill up the sample cell. Within the app, you select which test you're going to do. So you've just grabbed the alkalinity strip. You would select alkalinity in your app from the select test list. It will communicate. It's two-way communication. So it will communicate one way to the device till it's doing alkalinity. You hit 0 and then read. You dip the strip in the water for the 20 seconds. It gives you a 20-second countdown on the screen. You throw that strip away, and then it will, after the 20 seconds, submit that information back to your phone for a result.
So I'm looking here. I can get, it looks like I can get total hardness, calcium hardness. Is that right? Calcium hardness?
Yep.
And sulfates as well, right?
Right.
So the advantage of that is I can measure all this right at home and know exactly what my water is, right?
Yeah, you can actually get a measurement for all 6 of the ions we had described earlier. You can do alkalinity, which is a measure of your carbonate and bicarbonate ions. You can do sulfates. You can do chlorides. You can do total hardness and calcium, right? So the total hardness is a measure of both the calcium and magnesium ions combined. And then what the app actually does is it will do a calculation to subtract the calcium ions from the total hardness result and give you a magnesium result. The same for residual alkalinity. It will take the amount of hardness in your water and it will take the amount of alkalinity that you've got, do a quick calculation, and determine what your alkalinity will likely be after the brewing process or in that mash process.
Awesome. So, I mean, you can start with, for example, I actually live in a place where I have a well.
Mm-hmm. Yeah.
And so I get the water right out of the well, pumped right out of the well. And I don't have a water report I can rely on from the local municipality, but I can use a kit like this to measure it directly, right?
Absolutely. Yeah.
Awesome.
And it's simple.
Yeah, it is pretty easy to use, actually. It's a very nice kit. So, Christian, once you get all the data uploaded to the app, what can you do with it there?
Well, all of the data gets uploaded into the app into a result setting where you can add it to a specific customer, a specific site. So if you're doing, let's say you're doing a certain brew one day or 1 week, and then you can save that into a results history. And then when you go to do a separate brew or a separate type of composition water, you can do that on a separate site and save all of this into your results history, which can then be uploaded to your PC as an Excel file through email. When you add the results to the Excel file, you can import them wherever you'd like, or graph them, or anything you'd like to do with that. As well as in the app, you can update the tests as needed whenever we release an update to the Google Play Store or the App Store.
So that gives you the ability to potentially add new tests or new features, right?
Yeah, absolutely. Residual alkalinity and sodium calculations are 2 things that we've actually just added this year specifically for the brew market. So we're constantly trying to innovate and bring new things to the playing field. Whenever you buy the instrument, you've got that instrument for life, and all of the innovation comes through the app, and it's all through we'll push out an update. You never need to replace it.
Now, I'm sure one of the questions a lot of people have is how accurate are the tests? How accurate a picture do you actually get from this device? Yeah,
that's one of the most common questions we'll see. So one thing we like to talk about when we're talking about accuracy is the difference between limits of detection, accuracy, and precision. So some people, when they're asking that question, they really mean how low can I go? Or how high can I go with my measurements? It varies from test to test, but we have very competitive limits of detection. We use industry standard chemistries, and we've paired them with some of the most innovative technology so that we can get really low in our detection. The next part of that being precision. By using the photometer instead of the human eye, it takes out a lot of the variability, so we're allowed to be a lot more precise, down to 0.01 parts per million in some cases. That's down to parts per billion even. So,
wow, yeah, I mean, most of us only care about parts per million, really,
right.
at the homebrew level.
Right, exactly. So it gives you that added level of precision, and perhaps the most important one is the accuracy. Is if it's giving me a result, can I rely on that number? All of our tests have been verified in our research lab, and we've used reference methods from numerous different competitors, and we are really we stand behind our product. So we say that we've got a really accurate test that gives you really precise results with competitive levels of detection.
So, so what are we talking about for, so let's say those 6 water ions, how low can you go, or how accurate can it be?
Let me grab my reference sheet right here. So for our alkalinity, our range is from 11 to 200 with 7.5% accuracy. What that means is 7.5% deviation. If you get a result of, let's say, 100 parts per million, you can be confident that that is between 93 and 107, somewhere in that range.
Right.
What you'll actually see, and what I've noticed myself through my own testing, is that a lot of times it will be even more consistent than that. When you're using the same reagents over and over again. For example, let's say the true value is 100. I might get 98, 99, 101, nice tight grouping, but then someone else might do the test. They might be using the strip a little bit differently, not going at the same pace or something of that nature. And they might be getting 93, 94, somewhere in that range. So there is a little bit of a range that you can expect, but it is, as long as you're being consistent with your testing, it's quite consistent. So that's alkalinity. For pH, currently we have 6 to 8.5. Then we have a separate pH that can actually measure lower. But for your composition water, this is not for your mash. This is for your composition water. You're going to be, like we had said earlier in the show, a little bit more alkaline. So that should be perfect for that.
So you're talking about measuring it with the pH, not the pH meter, right? That's with the test strip.
Right, the pH test strip.
With the IDEP, yeah.
For the hardness, the calcium levels, the calcium hardness, 19 all the way up to 550. So I've had some brewers say, well, I would like my calcium way below 19 for my startup water, for my RO or my DI. The intent of this is not to make sure that you have perfectly pure water to begin with. It's maybe after you've done some additions and added some salts and different compounds to make sure that you've added them correctly and got to the levels that you desire. So we can measure from 19 up to 550 on that. And we have a low range total hardness that can measure all the way down to 1 ppm, all the way up to 80. And then we have a high range total hardness that can measure from 60 up to 500 plus.
And that's certainly within the range that most brewers are using.
Yeah. The difficult part about the total hardness is a lot of brewers will aim for that 60 to 80 level where those two tests overlap. So would it be better to use the high range or the low range total hardness? In general, we suggest that you use the low range if you're anywhere below 80. If you're anywhere above 80, then you should probably go with the high range.
Cool. Well, let's talk for a minute about the accuracy of the pH meter. What is that?
So that gives you a resolution of 0.1 ppm. So that means that you'll read to the nearest 0.1, and it is 0.1 accuracy as well. So plus or minus 0.1, meaning if you get a reading of, say, 5.3 in your mash, you can be confident that's either 5.2 or 5.4, somewhere in that range. Depends on how recently it's been calibrated, things like that. You have to leave in a little error for different situations, but at worst, you get the 0.1 accuracy.
Cool. So I mean, you get a very accurate test, really. Is it comparable with what you might get from a lab if you send it off to a lab?
Yes, it is. Most labs are actually going to use similar method. They might use a little bit more expensive instrumentation. For example, our laboratory has a pH probe, very similar to that one, but it's a benchtop pH probe as opposed to a handheld. Just a little bit more sensitive, but it's the same technology, so you'd be getting comparable results.
Awesome.
Mm-hmm.
Well, is there anything else you'd like to add regarding either the test kit or the pH meter?
I think that more or less covers it. I think it's a useful tool to the home brewer that's trying to elevate their brew and really dial into their specific flavor profiles that they're going for. I think anybody that is sending out water to be tested, it's more economical. I think for anyone that's relying on their water report from their municipality, it's more accurate. So it's definitely something that the more advanced brewer can look into to acquiring to dial in their brew water.
And not only that, obviously, having something like a pH meter gives you a lot more control over your mash if you're all grain brewing, right?
Absolutely, and limit the number of problems you might run into in that brewing process.
Well, Christian, I really appreciate you coming on the show and talking to us about water. Thank you for being here today.
Thanks, Brad.
And again, my guest today was Christian Krzykwa, who's a technical product manager for Industrial Test Systems. They make water quality test kits, including the Smart Brew test kit shown here. Christian, thank you again for coming on the show.
Thanks.
Great having you. Thanks again to Christian Krzykwa for joining me this week. Thanks also to Craft Beer and Brewing Magazine, where you get your 15% discount on their magazine or anything in their store if you use the offer code BeerSmith 2016 when you shop at beerandbrewing.com. Again, use the offer code BeerSmith 2016 when you shop at beerandbrewing.com. And also Anvil, the new line of brewing equipment from Blickman Engineering. Kettles, burners, and accessories built to last. Get durable, reliable, high-quality brewing equipment with Anvil at anvilbrewing.com. Again, that's anvilbrewing.com. And also BeerSmith software, the industry standard for home and professional brewers, lets you design great beer recipes and brew with confidence. Download your free 21-day trial from beersmith.com today. Thank you for listening. I hope you have a great brewing week.